As we learned in the previous lesson, the act of writing a program for your robot is essentially just putting together a list of instructions telling your robot what to do. In this lesson, we answer the question, what kinds of things can I instruct my robot to do? The answer is that you can really give the robot two kinds of instructions. Robots can sense things, just like we humans are able to sense with our eyes and ears and so on. Robots can sense things too. How bright is it around the robot? How noisy is it around the robot? Is the robot touching something? Is the robot near something? The robot can also do things. Just like we humans can move and draw and speak, you can give your robot an instruction to move forward 10 inches or maybe move forward for 20 seconds. You can instruct your robot to draw a picture of a smiley face or googly eyes on its little screen or print out a message on its screen. And you can even instruct the robot to say one of several pre-recorded phrases out loud, like good morning or fantastic, or get the robot to play a sequence of musical notes in the order that you specify. The Educational Robot Kit comes with 4 different kinds of sensors, also known as input devices. By sensor, we really just mean a fancy Lego piece that the robot can use to sense what's going on in its environment. If you have a brand new kit, all of the sensors can be found in this large white box. They all look a little bit Lego-y and a little bit geeky. This first sensor is called a touch sensor. You actually get 2 of these with your kit. The touch sensor has this little orange piece on the end, and if you touch that orange piece, you will find that you can push it in a bit. The robot can check whether the orange button on the touch sensor is pressed or released. If the button is pressed, the robot figures that the sensor is touching something. If it's not pressed, well, the robot knows that the sensor isn't touching anything, though of course some other part of your robot may be touching something. This second sensor is called the light sensor. The light sensor tells the robot, on a scale of 0 to 100, how bright it is in its environment. 0 means it's pretty dark, and 100 means it's super bright. If you buy the commercial kit, instead of a light sensor, you'll get what's called a color sensor, which can sense light and also sense 6 different colors. The sound sensor is kind of fun. It's essentially just a fancy microphone that tells the robot how noisy its environment is. Again, it uses a scale of 0 to 100, where 0 means it's very quiet and 1 means it's very loud. I had a teacher in one of my classes say he was going to write a program to help his students keep the noise levels down by having the robot react whenever it got too loud in his classroom. The ultrasonic sensor is the coolest sensor in the box. It's used to tell you how far away the robot is from an object that the sensor is pointing at. LEGO claims that it can detect objects up to 100 inches away. Some of that depends on how smooth and how large the objects are, though. You can actually ask the robot to report the distance in inches or in centimeters. You get back values between 0 and 100 inches or 0 and 250 centimeters. If there's nothing in front of the sensor, it'll just return the maximum reading. So 250 centimeters may mean that there's an object 250 centimeters away, or it may mean that there's no objects in front of the robot. Okay, so now we know something about what robots can sense. What can they do? If you want to be super geeky, you should say that the robot uses its effectors or its output devices to do stuff. But that's really just a fancy way of saying the robot has special parts that allow it to do things like move or make a sound. Let's look at the special parts that come with your robot. The motors are probably the most important. You'll get 3 of these in your kit, though you only need 2 of them to build the standard robot that LEGO gives you the instructions for in the booklet that comes with the kit. The robot can send a command to tell the orange part of the motor to spin forwards or backwards at a certain speed. If you connect the orange part to a wheel and the robot tells the motor to move, then presto, your wheel moves. This big white box is what LEGO calls the NXT Intelligent Brick, though I'll mostly refer to it just as the NXT Brick. It's actually the most important part of your kit, and we'll talk a lot more about it in a minute as well as in subsequent lessons. On the NXT Brick, there's a small screen, and the robot can display pictures and words on this screen. The brick also has a built-in speaker, and the robot can play pre-recorded sounds and musical notes through its speaker. Some of the earlier educational Lego kits also came with a lamp brick. It's pretty boring, really. If you connect one of these up to your robot, the robot can command it to light up. If your kit didn't come with one, don't worry about it. We're not going to use it. As I said, this NXT brick is essentially a small computer and is really the brains of your robot. On the bottom side of the brick, you'll find these 4 sockets numbered 1, 2, 3, and 4. These are called the sensor ports. You'll use some cables that look a lot like phone cables to connect your different sensors into the sensor port sockets. Up at the top of the brick, you'll find 3 more sockets labeled A, B, and C. You will use the same cables to connect your motors and lamp brick, if you feel like it, into these sockets called the motor ports. Up on top, you'll also find a socket labeled USB. You will connect the RCX brick to your computer using a cable that comes with your kit. It's actually a standard USB printer type cable. By the way, you won't break your robot if you plug a sensor into a motor port or a motor into a sensor port by mistake or by writing a weird program. If you do plug something in wrong, your program probably will not work the way you want it to, but nothing will be broken. While the Lego robot parts are very robust, it's a good idea not to drop your robot or drive it off the table. The robot may very well survive the drop, but it's a good idea to avoid getting into such situations. Some teachers require their students to always run their programs on the floor. Others use specially built tables with a lip around the edge to prevent the robot from driving off. Let me give you an overview of what it is you're going to be doing. This may seem like a lot, but don't worry, we're going to take it all very slowly and go through everything step by step in future lessons. We're going to start out by building a robot, and after that we'll write our first program. Remember, that's our recipe with instructions for the robot to follow. We're going to be writing our programs on a computer. Once the program is written, we will hook up the robot to the computer using the USB cable and send the program to the robot. Finally, we'll unplug the USB cable from the robot and tell the robot to run our program.